Here we're going to look at some examples on finding and determining the greatest common factor of some sets of numbers. So your greatest common factor is a single factor that is common to all terms that you have within your set. Now there are many ways that you can go about trying to find a greatest common factor. The method that I'm going to use to show you is prime factorization, and I'm going to show you why using the ideas behind prime factorization is one of the quickest ways to identify what a greatest common factor might be. So if we look at these three numbers, we have 16, 40, and 56. Now the reason I'm going to use prime factorization is because if you were to look at just the individual factors, sometimes you can get lots, like really large lists. And if that's the case, it could take you a good long while to write all the factors down, and it might make trying to find the greatest factor in common a little difficult. Prime factorization shortens up the idea. So if we start with 16, remember prime factorization says that you are going to divide out a prime number or a prime factor. So 16 is even, so I know right off the bat I can take out a 2, and when I do that I have 8 left over. 2 is a prime number, 8 is not, so I need to do it again. 8 is going to reduce down into 2 times 4. 2 is a prime number, 4 is not. My 4 can break down even further into 2 and 2. So here what you can see is that I have broken my term down to its prime numbers. Now I need to do the same thing to 40 and 56. So let's take a look at 40, and again there's multiple ways that you can go about breaking these. 40, one thing that you can see is that 40 is the same as 4 times 10. Now with that, neither 4 or 10 are prime, so we would break. 4 is going to reduce down to 2 and 2. 10 is going to reduce down to 5 and 2. 2 and 5 are all prime numbers, and so that's how you know you can stop. Now the last one we have to look at is 56. So we're going to break 56 down. I can pull a 2 out, leaves me with 28 behind. And then here I can pull a 4 out, leaves me with 7. And then my 4 can break down into 2 times 2. Okay, and so now I have all of my primes. So the first thing that you want to do is you want to kind of identify what is common. So I have a 2 in my first one. I've got a 2 under my 40 and a 2 under 56. But now if you look, I have another 2 under 16, another 2 under 40, another 2 under 56. I can go one more. I have 3 under 56, I've got 3 under 40, and I've got a third under my 16. Now if I look, the only thing that's left is a 2. Under 40 I have a 5, and under 56 a 7. What that means is that my greatest common factor is going to be 2 times 2 times 2, which is going to give me 8 as a result. Okay, so that's a very quick way to be able to look at the greatest common factors and determining what they are. Okay, so let's look at this next example here, and I'm going to go ahead and show you how to find your greatest common factor using just straight factors. So if we look at 30, this is called creating a factor tree. So 30 would break down into 1 times 30. You would have 2 and 15. We would have 3 and 10. And we would have 5 and 6. Now, the thing that gets complicated with your factor trees is you would really have to make sure that you hit every single factor. And the bigger the numbers or the more factors you have, the easier it is to skip or leave off a factor. Okay, so you really need to make sure if you're making the factor trees instead of prime factorization that you pay very close attention to what those factors are. Okay, now if I look at 42, my factors of 42 are going to be 1 and 42. I'm going to have 2 and 21. I have 3 and 14. And I have 6 and 7. And then I need to look at 54. So under 54, I've got 1 and 54. I have 2 and 27. I have 3 and 18. And I have 6 and 9. So the first thing that you want to do is you want to look at what do these all have in common. Well, they all have a 1. They all have a 2. They all have a 3. Only this one has a 5. If we go to 6, notice I have a 6 under 30, 6 under 42, and a 6 under 54. And that is the highest number that they have in common. Because that's my highest number, that means my greatest common factor is 6. Okay. Now, as a side note, what if I had done the same thing using prime factorization? So if I looked at 30 and I wanted to do my prime factorization for 30, well, I know 1, I can pull out a 3, leaves 10 behind, and my 10 is going to become 2 and 5. I know my 42 is going to become 2 and 21, and my 21 becomes 3 and 7. And I know my 54 is going to become 2 and 27, which reduces down to 3 and 9. So if you look at these, each one has a 2, each one has a 3. Therefore, my greatest common factor would be 2 times 3, which is 6. Now if you look at that, notice we came up with the exact same result, but personally I think the prime factorization goes a lot faster than trying to do factored form. Okay, so just something that you can rattle around as you're working some of these problems, that prime factorization a lot of times ends up being a lot faster. Okay. Now, I do have a couple more examples, and these examples are going to include some variables, so we're going to kick things up a little bit. And I'm going to show you how to do prime factorization under both, because you can work it even though you have a variable. So here, the first thing we would look at is 8a cubed. So when I look at 8, there's a few things that you can see. First of all, this becomes 4 times 2, which reduces to 2 and 2. Now, the other thing that I have is my a cubed. So when I'm looking at this, I have cubed, I have to the 4th, and I have squared. So here, my a cubed can become a and a squared. Okay. Now, I can continue to break them down, or I could stop here and just see what happens. Now, the middle one I have is 16a to the 4th. So my 16 here is going to become 8 times 2. We know 8 can become 2 times 4, and my 4 breaks to 2 and 2. And then we know a to the 4th is going to become a squared and a squared. And then last but not least, I have 24a squared. 24 can become 6 times 4. My 6 will break down into 2 times 3, and 4 breaks down into 2 times 2. Now, with this, just like before, we need to identify the ones that are the same. Okay, so let's start with the numbers. Notice I have 1, 2, 3, 2's. I have 1, 2, 3, 4, and I have 1, 2, 3. So here, my 3 2's are going to be what's in common. And then if we look at the variables, I have a and a squared, a squared, a squared, a squared. So a single a squared is also my common factor. So in this case, when we're looking at your greatest common factor, we would have 2 times 2 times 2 times a squared. So in this case, this would give you 8a squared. And that's the greatest common factor of all three terms. Alright, so let's do one last one that's slightly more complicated. Notice I have two variables in each one. So let's start again. I've got 28c d cubed. Now notice I kind of gave myself a tiny bit of space between them. That's going to help keep your C squared. That's going to help keep your factorization a little bit separate so it's not quite so cluttered. Another trick that I like to use is, notice my 28 I can break down into 4 and 7, and so what I did is I put my prime factor towards the middle or towards my other terms. My unprimed factor is on the outside, which gives me more room to be able to break it down without creating a cluttered mess. So we have broken 28 all the way down. My c squared becomes c times c, and then my d cubed can become d times d squared, and that's the first one. Okay, so now let's look at the next one. I have 14c cubed d squared. So my 14 again can become 2 and 7. My c cubed can become c times c squared, and my d squared can become d and d. And then the last thing that I have is I have 42, and then it is c d squared. 42 is going to break down into 7 times 6, and 6 breaks down into 2 times 3. C is totally by itself, but then D can break down into D times D. And so in this case, we have to look at what's the same. Okay, so if you notice, in each of these I have a single 2. So my 2 is the same, and then I also have a 7. So 7's the same. If we start to look at my C's, notice here I have just one C, so that means it's a single C that gets pulled. And then if I look at my D's, notice I have a D squared and a D. I've got a D squared and D squared, and so we would use the D squared as your GCF. So in this case, what this means is that my greatest common factor is going to be 7 times 2 times C times D squared, which is going to be 14CD squared. Okay. And so that's it. That's everything that you need in order to identify a greatest common factor using the ideas of, say, prime factorization to reduce your terms down. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this video, and I'll see you next time.